I'm Paige from SMK Tengku Ampuan. In today's video, I'm going to show you how to create a sweeper board. I call it sweeper. So this sweeper or the sweeper board is going to be a robot that is going to be sweeping away any obstacles or anything that is blocking in front of it. So it's like you can think of it as a clearance board. It helps you to clear the road or clear the pathway. So maybe anything that is in front of it, maybe a bottle or anything. So we assume it as an obstacle, so it wants to clear away to make a empty or clear pathway. Right, so that's about it. Let's get started. Okay, so before we get going, first I'm going to explain what we'll be doing next. So I'm going to break the build into three main parts, so three main modules. So I'm going to have my first module would be the obstacle avoidance module, and then my second module would be the driving module, and my third module is the sweeper module. Okay, so the first module or the obstacle avoidance module is going to act as the input unit. So we have three ultrasonic sensor here. So all these three ultrasonic sensor is going to be sending the reading back to Arduino, distance reading back to Arduino, and then Arduino as the microprocessor will process and control our output unit, which is the driving module and the sweeper. So driving module, we're going to be using differential drive idea to move our motor. So you can check out my previous video regarding differential drive. And for sweeper, it's pretty much just a servo that's going to rotate towards left or towards right. So it will sweep away any obstacles that's in front of it. Okay, so that's pretty much about it. Okay, next we're going to look into the 5 scenarios that we want our sweeper board to achieve. Okay, so the first scenario is that when there is no obstacles in front, what we're going to do is to ask the robot to move forward. Okay, so just move forward, move forward. And second scenario is that now there is obstacles in front. So what's going to happen is that it's going to move forward and then it's going to detect, the front detector is going to detect the presence of obstacles in front. So what's going to happen is that we need to sweep away these obstacles so we can have a clear road. Okay, to sweep away, the problem here is that we don't know where to sweep. The robot does not know whether to sweep left or sweep right. Okay, so to choose where to sweep, we're going to ask our left and right detector to check left and check right. So we're going to check if left or right has any obstacles, and then we're going to sweep towards the direction that has no obstacle. Okay, so the third scenario is that after checking, we find out that left has no obstacle, left has obstacle, right has no obstacle. Okay, so what we can do is to make the sweeper or the servo to turn right, and then so it can push the obstacles towards right, and then to assist, to help to push a little bit more, I'm going to ask my robot to move or turn right. So this helps to add additional force to help you push away the obstacle, just in case the obstacle is maybe big or heavy. Okay, so that will be much more easier rather than asking the sweeper to be working alone. Okay, now when we combine scenario 2 and 3 together, what we can see is that the front detector detects obstacle, it's going to stop for a few seconds, and then it's going to need to check left and check right. So after checking comes in the third scenario, which is obstacle is on the left, no obstacles on the right. So what we're going to do is sweep right, move the car towards right to help assist pushing the obstacle. Okay, so that's scenario 2 combined with scenario 3. Now we look at the fourth scenario is that now the obstacle is not on the left. Now after checking, we see obstacle on the right, but no obstacle on the left. So same thing, we're going to push it towards left, and then same again, you're going to ask the car to move a little bit, just a little bit to help to push the obstacle. Okay, so when we combine scenario 2 and 4 together, what we see is that front detector detects obstacle, stop for a few seconds, check left, check right. Fourth scenario is after checking, right has obstacle, left has no obstacle, so push the sweeper, sweep towards left, and our car drive towards left a little bit to help push it. Okay, so that is scenario 2 and 4. Now we look at the fifth scenario, which is after checking, left and right both has obstacle. So what we do is that we're going to reverse and then make a U-turn. Okay, so when we combine 2 and 5 together, what we see is that front detector detects, check, we're going to stop a few seconds, and then we're going to need to check left and check right. The fifth scenario is after checking left and right, both has obstacle, so we're going to reverse and make a U-turn. So that's roughly the 5 scenarios that we will be doing today. Okay, and one more thing is that what you need to take note is what is the practical range should you detect. Okay, so we want to make sure that when we ask our detector to detect, right, for all three sides, we need to detect at a short range. Okay, we need to detect obstacle at a shorter range. Why is that? Is because imagine now I set it to detect obstacle at a range of 20, anything below 20. So let's say 20 is this much. So to sweep away this obstacle here, you're gonna need a long sweeper or a long rod to actually reach and sweep to reach this obstacle here. So it's far. But and it's not practical to actually put such a long sweeper onto your robot, right? So to simply solve this problem, what we do is to just ask it to detect at a nearer range. You can set it 10 cm, 5 cm. I'm going to set it to 6 cm. Okay, so 6 cm will be enough for me to sweep away the obstacles in front of me. Okay, so that's the first part that you need to take consideration into. And the second part is that people might question, why actually do I need so many times of checking? So why do I need to check for left and check and right? So one of the main reasons is because that we want to know whether left and right has obstacles, so we can decide where we should sweep the obstacle towards, right? So imagine now, right, if you don't check, right, if your robot does not have the checking for left and right, what's going to happen is that whenever it detects a front obstacle, it's going to decide to sweep left or right. Your robot is going to decide based on how you code it, right? So maybe you code it to sweep left and right, okay? Sweep left and then sweep right. So what's going to happen is that it's going to sweep, but the problem here is that if you are unlucky, if you're unlucky, there is obstacles here, and then your robot is asking you to sweep towards the left, so it's going to have additional obstacles to help to push away. So this result in your robot or your sweeper need additional force to push it away. So that's not a good idea to help to solve this, right? So to just make it better, just check whether which side has no obstacle, then we sweep towards that side. Okay, so that's one part. And actually the ultimate reason, or the most important reason why I added this feature, is because that I want to avoid damage to my robot. Okay, now imagine, right, what your robot is actually doing is that when you have no checking mechanism for left and right, so what your robot is going to do is that it detects front has obstacle, it's going to sweep away, move forward, sweep away, move forward, sweep away, move forward. So it's only there's only one motion involved. It's only going forward, 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 forward. So imagine now you are in a room, and in the end you keep moving forward, sweeping, moving forward, sweeping, moving forward. Eventually you will reach a wall. Okay, when you reach a wall, at this point your robot is still detecting it as an obstacle, but since robot does not know what actually is in front, it does not know if that is a wall, so it's still going to detect it as obstacle, and it's still trying to sweep here. So it's going to sweep left, sweep right, sweep left, sweep right. But what we know is, in the end of the day, after 5 minutes, 10 minutes of sweeping, the robot is still going to be there, same position, trying to sweep the wall. So it's impossible to sweep away a wall. So now if we can solve this problem, is because that when we check, we know that everything is blocked, so we cannot sweep any direction, so we just make a U-turn. So this helps me to reduce damage, rather than me constantly asking the robot to be sweeping this wall until and have no conclusion, right? The only thing that's going to happen is that your sweeper or your robot is going to be damaged, because it's the wall is hard and it's trying to constantly sweeping the wall. So that's not a very good idea to do. So simple solution is just that I added the checking mechanism, and then whenever left, front and right is being blocked, then we just simply make a U-turn. So one good benefit of this is that you can have involved more motion. You can, rather than just moving forward only one motion, that's kind of boring, and so we can have multiple motion, just moving forward, U-turn, and then left and right, and so on. Okay, so that's pretty much of the 5 scenarios that we're gonna take in to be doing today. Okay, so to start by building our circuit, first I'm going to start by building our motor module. So for motor module, we're gonna need a motor driver, L29 3D, and we need 2 hobby kit motor and external power supply 9 volt. So 9 volt is so that we can have enough power to power up the motor. 5 volt from Arduino will not be sufficient enough. Okay, next for sweeper, we need a micro servo, so we're going to add servo. Okay, so next we move on to our input module, which is our obstacle avoidance module. So we need 3 ultrasonic sensors, which we're using HCSI04. Okay, so these are all the components that we need. So next up, we start by wiring up our motor driver. So I'm going to connect ground to ground, okay, ground to ground, all to ground to ground, and then I'm going to connect this bottom ground to our 9 volt, negative terminal on 9 volt, external 9 volt, and then the top ground here, we're going to connect it back to Arduino, grounded on Arduino. And then you're going to connect 5 volt on the Arduino Uno. We're going to connect it to our power 1. So this is going to be used to power up the IC chip on the motor driver. And for power 2, we're going to connect it to the positive terminal of our 9 volt. Okay, so next up is to connect the enable 1, 2 and enable 3, 4. So enable pins are used to control the speed of motor again. So we're going to connect the enable 1, 2 to PWM 6 and enable 3, 4 to PWM 5. Okay, next we need to connect input 1, input 2, input 3 and input 4. So input 1, we're going to connect it to digital 8, input 2 to digital 7, input 3 to digital 3 and input 4 to digital 4. Okay. Okay, next I'm going to connect the output 1, output 2 to motor 1 or left motor, output 4 and output 3 to our right motor, which is motor 2. Okay, so that's it for our motor driver. Next we move on to our sweeper module. So for our sweeper module, we're going to connect signal pin to pin 9. Power that crane. Okay, so for power, the VCC, we're going to just connect it to 5 volt on Arduino. And then for the ground, we'll just connect it to ground. Okay, so we're done here. You can use a breadboard if you kind of feel that powering up such a pad is kind of confusing, so you can just power it up using breadboard. Okay, so next we move on to our obstacle avoidance module. Okay, so this one. Okay, so first up is to supply power to all our modules. So what I'm going to do is just to connect all this VCC together. So what I'm going to be doing is the same as the previous tutorial that I've taught on the previous video. You can see how we do it. So what we're doing here is actually again using this main 5 volt. We're going to supply the 5 volt to all modules. So everyone that is connected to all this 5 volt here will receive the same, the VCC here will receive the same 5 volt. So actually just using one cable to supply for everyone. So same for the GND, we are using one main cable to supply GND for every module. Okay, so again you can use breadboard if you want to power up the. You can manually connect the breadboard, or you can use just manual connection one by one to the 5 volt. But normally if you're building this project into a real device or into a real robot, soldering or using PCB boards would be a better idea. Okay, so next to power up signal cable, so I'm going to start by this right detector. So I'm going to connect trigger to analog 0 and echo to analog 1. Okay, so for front module, we're going to connect trigger to digital 11 and echo to digital 10. Okay, and for our right detector, we're going to connect trigger to pin 13, echo to pin 12. Okay, so that's it for our circuit. Alright, so now to the fun part, which is coding. Okay, so first up is we'll need to create 3 variables. So I'm going to call it front disk, left disk, and right disk. So each of this is going to be used to store the distance reading for our ultrasonic sensor. Okay, and then next is that we want to set the default state or the starting state for our sweeper to be at the neutral position or center position. Okay, so for that we're going to set our servo to be at the center position. It's 90 degrees, and my servo is on pin 9. And then we're going to add about a 1 second delay so that the servo have enough time to position itself. Okay, so next up we'll start by checking our front detector. We're going to start by reading the front distance, whether there is obstacles or not. So we're going to read on ultrasonic sensor. Trigger is for front detector, trigger is on pin 11, echo is on pin 10. Okay, after reading, we're going to use the control if then else to check if there is obstacle. So we'll use mathematics, this one. I need to check the variable front disk if it's more than 6 centimeter. More than 6 centimeter. So what we're going to do is moving forward. That is scenario 1, which is there is no obstacle. So I'm going to put a notation saying I'm moving forward. Then I want to ask serial monitor to print I'm going forward again. This is to help us to better see what our motion or robot is moving at that point of time. Okay, so to move forward, we're going to need both of this left and right motor to be rotating, the wheel to be rotating forward. Okay, we're going to need 4 of this. 1, 2, 3, 4. Okay. And then we're going to need 2 of this block. Okay, 2 of this block is used to control the speed. This is the enable pin. Okay, so enable 1, 2, 3, 4. Enable 1, 2 is on pin 6, PWM 6. Enable 3, 4 is on PWM 5. So we're going to set that 6 and 5. And then our left motor moving forward for left motor is controlled by pin 8. We're going to set that pin 8. And our right motor moving forward is on pin 4. Okay, and then for the reverse on left motor is controlled by pin 7. The reverse on right motor is controlled by pin 3. Okay, so now we want it to move forward, right? So forward for left motor we set it to high, forward for right motor we set it to high, and we don't want it to reverse on left and to reverse on right, right? So we set that to low. We don't want it to reverse, left motor no reverse, right motor not reversing. Okay, so while moving forward, we want it to move it at a very moderate speed. We don't want to be moving too fast, too slow. So moderate speed, half the speed, I would say. So it's 127. You can again set any number, the PWM value or the speed value. You can set it between 0 to 255. So I'm going to set it half the speed will be 127. Okay, so that's moving forward. Else, that means scenario number 2, where there is obstacles in front. Okay, which is front distance is less than 6 centimeters. That means there is obstacles. So what we do is first thing is to stop. Okay, so to stop, I'm just going to duplicate this. Duplicate. Bring it down here. I'm going to ask it to say I'm stopping. Serial monitor say that I'm stopping. Okay. To stop, we want everything to be off. Okay, no speed, not moving forward, not moving in reverse. So everything will be stopped, everything will be 0, everything will be low. 0, no speed, not moving forward, and not moving in reverse. Okay, so that's stop. So we're going to stop about 2 seconds, or yeah, 2 seconds should be enough. Okay, and then after stopping, what we're going to need to do is to check left and right, right? So to check left and right, I'm going to ask this set left and right. Okay, so we're going to set left distance, right distance. Okay, so left is going to read left detector, right is going to read right detector. Input. So the left ultrasonic sensor trigger is on pin 13, echo is on pin 12, and for the right detector, trigger is on pin analog 0, echo on analog 1. Okay, so after checking, comes in the third scenario is that obstacles is on the left, no obstacles on the right. So for that, we're going to use control if and else to make that scenario. If and else, and use this mathematics. We're going to need this block, and because we want to check left and right. Okay, this block. Okay. And check left distance has obstacle, which is left distance is less than 6 centimeter. Right distance has no obstacle, so right distance is more than 6 centimeter. Okay, more than 6 centimeter. So no obstacles on the right, so we're gonna sweep towards right. So sweep and move right. So I'm just gonna duplicate this block here. Okay, I'm gonna say it's sweeping left, sweeping right, sorry, because we have no obstacles on the right. Sweeping right. Okay, so to sweep right, we are asking the servo to be moving right, moving towards right. So we're gonna need the servo. I'm gonna ask servo. Okay, below here. Servo is on pin 9. To sweep right in my case is 0 degree. In my case is 0 degree. Okay, sweep right again. Every time we are using servo, we need to add a short delay, so we have time to move towards that angle or that degree. And then we want it to help your robot to be moving right, also to help assist to push right. So to move right, we need our left motor to be moving forward and our right motor to also be moving forward. But to make it move towards right, we need the left motor to be moving at a greater speed, so it can move forward more compared to this right motor, which is slightly slower, so it will overtake, so we can produce the turning motion. Okay, turning towards right. So set that to high, okay, but the speed is the one we're going to be playing. So speed on left motor, PWM 6, we're going to set it to greater speed, so about maybe 200. And this one will set the right motor to 150, so it's a slower speed, 150. Okay, and both the wheel is going to be moving forward. Okay, it's just that when left motor is moving at greater speed and right motor is moving at a lower speed, so it's going to overtake. Left motor is going to overtake, so we can produce the turning motion towards right. Okay, so that is that, and we're going to set a short delay. Maybe ask it to move about 2 seconds. Okay, we're going to ask it to turn right for 2 seconds. Okay, so else, that means now is the fourth scenario, which is now obstacles is on the right, no obstacles on the left, so we sweep and turn left. Okay, so for that, we're just going to copy this, and then we're going to change the condition, which is left is more than 6, that means no obstacle, and right is less than 6, has obstacle. Okay, we're going to sweep left, so I'm going to change that to left. Serial monitor pin sweep left. Okay, so to sweep left, my servo has to be rotating to 180 degree. Okay, 1 second delay. Again, the same concept. We want to sweep left. We want our robot to be turning towards left. So now this time is that right motor has to overtake the left motor. Okay, so to make it overtake, we ask the right motor to rotate at a greater speed. Okay, so now we're just going to change this. Right motor 200, move faster, rotate faster. Left motor rotates slower, 150. Okay, move for about 2 seconds. Okay, so next is that else, that means it's the fifth scenario, which is left and right is being blocked. Okay, so left and right being blocked, what we do is the first thing is we want to reverse and then make a U-turn, right? So to reverse, I'm just gonna duplicate the stop block. Okay, bring it down. Oh, we copied everything, duplicated everything, so we're just gonna remove those that we don't need later on. Okay, bring it here. So we only need until the weight here. The others, we just move it to the pin. Okay. So this time we are going in reverse, and we are saying reverse, serial monitor pin reverse. Okay, so to reverse, what we want to do is that we want left motor to rotate in reverse and right motor to rotate in reverse. So to reverse on left motor is controlled by pin 7, so we set that to high. And pin 3 for right motor, so we set that to high, so it's reversing. And reverse, definitely we need to give a little speed for the motor to rotate, right? So again, we're gonna rotate at a moderate speed or about half the speed, so it's 127. 127. Okay, I'm gonna reverse for 2 seconds, and then we're gonna make a U-turn. So make a U-turn. I'm just gonna duplicate this block, bring it down here. Okay, and then I'm gonna say U-turn. U-turn. Okay, serial monitor print U-turn. Okay, so now to U-turn, what's the idea is that, let's say I want to U-turn, so my U-turn I want to turn towards right, right? Okay, so to U-turn, I want to make this motion. So I want my left motor to overtake my right motor, but I want it to U-turn at its own position. So what we do with that is that now, instead of asking both left and right to be moving forward, what we do is that we ask left motor to move forward and right motor to reverse. So this one helps to rotate at its own position, as per what we explained in differential drive last video. Okay, so set that left motor moving forward, set that on pin 8, and reverse on right motor is controlled by pin 3, set that to high, and we don't want it to reverse for left motor, we set that to low. We don't want it to move forward for right motor, we set that to low. Okay, so left motor moving forward, right motor moving reverse. Okay, and to assist in rotation, we're gonna set again left motor to moving at a greater speed and right motor to move at a slightly slower speed, so left motor can overtake the right motor. Okay, and wait 2 seconds. That means we're gonna U-turn about 2 seconds. Okay, maybe I'll set it to 3 seconds. So as previously I mentioned, so this depends on how long your robot takes to rotate. So if it's 5 seconds, you set it to 5 seconds. So for this case, I'm just gonna set it to 3 seconds. Okay, and if in case you are curious, right, why is the U-turn part here a little different than the turning left and turning right? So when we're turning right, what's happening is that we want it to turn right at the same time it's still moving forward. That is why we ask both the wheel to move forward. It's just that we use the speed control to control the turning of the direction. So when left motor overtakes, turn at a higher speed, it will overtake the right motor. So then it can turn right. But at the U-turn part, what we did is that we asked left motor to move forward and right motor to rotate in reverse. So what happens is that this helps to rotate itself or make a U-turn itself at its own place. So since the U-turn we don't need it to move forward, right? So we can just use it at its own place. You can check out the previous video for better understanding regarding differential drive. Okay, so that's pretty much for our code. Okay, so we're gonna start simulation and see if our code works. We'll start simulation, and you see the default state of the sweeper, it turns towards the center position, so it's not sweeping left, not sweeping right. And now for our front detector is 82, which is scenario 1 more than 6 cm, so it's gonna move forward, and you see serial monitor going forward, and both of them are positive 117 plus RPM, so both moving forward at half the speed. Okay, so now we're gonna see scenario 2 combined with scenario 3. So that means front has obstacle, left has obstacle, right has no obstacle. So we're gonna need to sweep the obstacles towards right hand side. Okay, so I'm gonna make scenario 3, and then I'm gonna make scenario 2. That's that. Okay, observe the sweeper. Okay, it turns towards right, sweeping towards right, sweeping right, and here we can see, okay, let's stop, okay, 0 RPM, stop, and then you see 180 plus RPM here, and the right motor was 137 RPM, so both are positive moving forward, but this one, left motor, is moving at higher RPM, rotation per minute. This one is a lower rotation, so left motor will overtake the right motor, therefore they produce the motion moving forward right. Okay, so that is for scenario 2 combined with scenario 3. So now we see scenario 2 combined with scenario 4, which is front and right motor front and right detector detects obstacle, and left detects no obstacle, so we sweep and turn left. Okay, so I'm going to make scenario 4, 4.5 cm, scenario 2, okay, and then you see the sweeper turns towards left, okay, sweep left, and then this is 180 plus RPM, and this was 130 plus RPM. So again, both are positive, so both are moving forward, just that the right motor has a higher rotation per minute, so it will overtake this left motor, so we can produce the rotation turning towards left. Okay, so now we look at scenario 2 combined with scenario 5, which is all the sides are being blocked. So this is already less than 6, so I'm going to make this less than 6 as well. Okay, and then comes in the second scenario, less than 6, 9, 7, 5, okay, less than 6. So what we see, it stops, reverse, and make a U-turn. So we see stop, after detecting the front, it's going to reverse negative 114 plus RPM, and then it's going to make a U-turn. So we see positive, okay, remember, we see again negative, positive 184 and negative 136. So this is the part where it's U-turn. This is moving positive, this is moving in reverse, which is negative, and it's moving at greater speed, this is moving at lower speed. So this is the part where we make the U-turn. Okay, so this is all the 5 scenarios, and it shows that everything works well. Okay, so that's all for today's tutorial. Thank you for watching.